When we're solving systems algebraically, that means not with a graph. It means by doing math on paper, right? We have to decide, are we going to use elimination or are we going to use substitution? So when you see a particular system, you have to decide what to use. And so the thing to remember is that elimination is good for when you have two equations that are both in standard form, where you have a number times x plus a number times y equals a number, right? You can see that both of these equations are in that form. I will choose to use elimination for this one, okay? And there's other situations in which I would feel that substitution would be the easier option. So on this one, I'm gonna write elimination on it, because it's really important that when you see a system that you're able to decide, excuse me, that you're able to decide what to use. In this case, elimination is the better option. And in fact, this is a perfect system for elimination because look what I notice. There's a 3x right here and a negative 3x sitting right above it. So I know that when I add these two equations, this is gonna cancel, right? I'm adding negative 3 plus 3, that's 0. 5 plus 2, that's 7. 45 minus 3, right? Now I'm adding, but it's negative 3, so that's 42. And I am well on my way to already having the value of one of my variables. I'm dividing by 7 on both sides to get y by itself, and I already see that y is 6. Okay, now I still need to find x. I'm going to just plug back into one of these equations. I'll choose this bottom one. So I'm going to say 3x, and notice this is a y value, so I'm plugging it in for y. Okay, so this is 3x. 2 times 6 is 12. I'm subtracting 12 from both sides because now my goal is to get x by itself. Okay, and I get x equals negative 5. Okay, now what I want you to be mindful of when you come over here is that here, when you draw the line underneath and you cancel, what's going to cancel is the y's. So you're going to end up getting the x value first over here. Okay, so this is going to be, when you do the work, it's going to say x equals a number, and you need to make sure and plug that number in for x. Okay, so just be careful. There's a common mistake is to say, like, take this 6 and plug it in for x, but it's not, it's a y value. Let's look at this next system. I notice again that these are two equations in standard form, right? A number times x plus a number times y equals a number. So again, elimination is the better option here. Elimination is going to be easier. However, this one, I don't have a situation where I can just add, right? I can't just add and see that these cancel out. So what I'm going to do is I'm going to observe, okay, I could cancel out the x's. That'd be one option. And I think to myself, if I were going to cancel out the x's, 2 times 5 is 10. So I would multiply and make this positive 10 and multiply and make this a negative 10. How would I do that? I'd multiply this one by 5. I'd multiply this top equation by 5, make it positive 10. I'd multiply this bottom equation by negative 2 and make it negative 10. That'd be one option. The other option is I could cancel out the y's. I'm going to do this one. 3 times 4 is 12. I'm going to make this one negative 12 and this one positive 12. Why am I going to make this one negative? Because it's already negative. So look, if I just multiply it by 4, 4 times negative 3 is negative 12. And this one I want it to be positive 12. 3 times 4 is positive 12. So when I do the math, 4 times 2, 8x, 4 times negative 3, negative 12y, 4 times negative 9, negative 36. Now, on the bottom, 3 times 5, 15x, 3 times 4, positive 12y, 3 times 12, 36. Now, here, this cancels. Negative 12 plus 12, that's where it cancels. 8 plus 15 is 23x. And here, negative 36 plus 36 is actually 0. So when I divide by 23 on both sides, x equals 0. So I have my x value. And let's plug back in and find y. So I'm going to take this and plug in, right? I'm plugging in 0. Notice I'm plugging it in for the x. And my goal is now to get y by itself. So 2 times 0 is 0. I'm going to divide by negative 3. And I get y equals negative divided by negative is positive. Now, Last thing, I'm going to check if this is a solution to these equations. Now, really what I should have been doing is I should have been checking my answer all along. When I got these answers, I should plug it back in and check. And certainly on the final exam, you should plug back in and check your answers, right? It would be crazy not to. But here, this is how you would do it. This is your x value. This is your y value. So I'm going to check. I'm going to see, does it work in this equation? And does it work in this equation? So let's start with this equation. I'm saying, okay, 3 times x plus 4 times y is going to be 2, equals -7. So 3 times -5 is -15. 4 times 2 is 8. -15 plus 8 is -7. So this says -7 equals -7. That's true. Let's check this equation. This says y equals, so instead of y, I'm putting 2. 2 equals -2 times -5 minus 8. Okay, so I'm going to bring down. Here I'm doing the math. Negative times negative is positive. 2 times 5 is 10. Minus 8. 10 minus 8 is 2. Yep. So see how it works in both equations? I need to have it work in both equations in order for me to circle, yes, it is a solution to the system.